All right, let's see. All right, we are now recording. Thank you so much for coming today, my pre-calc students. And if you couldn't make it, you'll see this later posted on the website. All right. Actually, I'm going to plug in my document camera here so you can't see my fun math shirt anymore, unfortunately. All right. So let's do this. All right, while I'm getting myself situated here, ask away. What can I help you guys with? Oh, there's some good chat happening here. That's what I was missing. Okay. All right, Morgan says, can you do one of the first sets of questions? Let me look at the review sheet to see what you're talking about. Are you talking about the equation of lines stuff, Morgan, there? Okay. Yeah, let's review just kind of that stuff in general real quick. So when we're talking about the equation of a line, there's two main forms that we've looked at. And the one that you're probably most familiar with is the slope-intercept form of a line. Slope-intercept is everyone's favorite, y equals mx plus b. So in that form, we know that the slope is m and that b is the y-intercept. And the form that we're, I think, less comfortable with using, but actually is pretty important for things that you'll do later on, and assuming we get to it in the study of like an intro to calculus, you'll see point slope form used a lot more often. So it's going to be y minus y1 equals m times x minus x1. So m is the slope of the line again, but x1, y1 is just kind of a random point on the line. It doesn't have to be the y-intercept per se. And then two other quick notes, because I know it's going to come up in those questions, is that if you have parallel lines, what that means is that we have equal slopes. And if you have perpendicular lines, what that means is you have negative reciprocal slopes. So the relationship there would be if you have m1, the other slope m2 would have to be -1 over m2 in that case. So let me actually do one of those questions then, Morgan, so you can see kind of what we're talking about here. If I go back to the review for a second, I'll look at I kind of like number 3 for some reason, not sure why. But number 3 is we want the equation of a line that's perpendicular to 4/3 x minus 2y equals 8. And it goes through the point -8, -11 in slope-intercept form. Okay, so slope-intercept form, as a reminder, what we wrote up top is, in the end, I want to be in y equals mx plus b. So that's the goal. And if I'm being honest, I probably wouldn't start with that form, because when I have just that random point that the line's going to go through, I like using point slope form. So the first thing I have to do is figure out what is going to be the slope of my new line if it's perpendicular to this line. So I'm going to quickly rearrange this equation right here and get y alone. So if I subtract 4/3 x to the other side, and then I go through and, oops, it's going to be a +8 there. And I divide by -2, we get this kind of not so nice looking fraction here, right? -4/3 divided by -2. Think of it as -4/3 times maybe like -1/2. So that's going to wind up reducing here to a positive 2/3 x. So the equation of that line is 2/3 x minus 4, the original line. So if I want to be perpendicular to that, a slope of a perpendicular line would be -3/2. So now that we have the slope in question and we have the point that's on the line, I'm going to write the equation in point slope form first. So when I do y minus y1, since y1 is the -11, it's going to become y plus 11 equals the slope of -3/2 times x minus x1. When you subtract the -8, it becomes x plus 8. And if it didn't say anything about slope-intercept form, I would have been able to stop right there. But since we have to go back to y equals mx plus b, the last few steps would be distribute the slope. That's going to be -3/2 x, and then that's going to be a total of 12 there, right? And then finally, if I subtract the 11 to the other side to get y alone, -3/2 x minus 23 would be the final equation in slope-intercept form. So I think what you'll see is if you look back at the very first day of Unit 10, that's where we did this information. And it was probably a lesson where I kind of flew real quickly through it because this is stuff from prior school years. However, yeah, I mean, if you haven't done practice with it in a while, I can understand why that would be something that we need a little bit of a refresher on. So was that good for that one, Morgan, or did you want to try something else there? Okay, perfect. And this was definitely a lot going on in this one. Like, it wasn't the cleanest looking equation to isolate y first to get started. Hopefully that negative reciprocal slope part was okay. If it's at parallel, I would have kept the same slope and done the same thing. I do like starting in point slope form if you're given a random point, and then doing some quick algebra to solve for y. What else can I assist you guys with? So again, if it's easiest, just feel free to unmute yourself. Or maybe you don't have questions. Oh, wait, we do. Addie says 13. I'm guessing 13 on the review sheet. Let me see if I can find that real quick, Addie. It's the one, solve the system using the inverse matrix method. Okay, that's definitely a good one to ask about because that is a question that, if you don't remember the inverse matrix method, can be tricky to solve. This is the last lesson from the unit. It was the day 6 notes, so I guess the video from Monday. Let me copy the question down quick, and then we'll talk about it. So we get 4x plus 5y equals 7. 2x plus 3y equals 5. Okay. We've talked about a few different ways to solve this type of system. We've done it with just, kind of basic row operations, but the inverse matrix method is the following. Get the system in the form ax equals b. And in the end, you want to solve for matrix X. And I'm hoping that we would have already watched the Monday video. But to solve for matrix X, it's not as simple as just dividing both sides by A. Because we don't have a process. Remember that these are all matrices. We don't have a process that allows us to divide matrices. But we do have a process for multiplying matrices. So we'll get to that part in a sec. But if I do matrix A, what is matrix A? It's the coefficients of the left-hand side of the equations. So that's going to be 4, 5. And 2, 3. Matrix X is going to be the variables that we're solving for, X and Y. And then matrix B is what's on the right-hand side of the equations, which are 7 and 5. Okay. Once we're in this form, to solve for this matrix right here, what we're going to wind up doing is multiplying both sides by the inverse. And I'll just show you real quick why that makes sense. I believe I did it at least once in the notes on Monday, maybe twice. I probably even used the term left multiply by A inverse. I'll explain why we have to left multiply here. When you multiply a matrix times its inverse, you get what's called the identity matrix. On the right-hand side, I'm just going to leave that as A inverse B. And when I talk about the identity times matrix X, the identity times any matrix is the same matrix again. So I can solve for X by doing the product A inverse times B. And the reason why A inverse has to be on the left side of B is that if I reversed it and I wrote B times A inverse, that product wouldn't even be possible according to the rules for matrix multiplication. Okay, after all that, now what do I have to do? I have to take this matrix up here, that little 2 by 2, and find its inverse. So how do we find the inverse of that matrix? You augment it with the identity matrix to start. So that's going to be the first step. I'm going to show you how we'll do it by hand. And then once we're done doing it by hand, then we'll take a look at just quickly on the calculator what the solution would look like there. Okay. So once I do that, the goal is to make the inverse on this side. Sorry, the identity on this side. So to make the identity, you're going to take row 1. You're going to multiply it by a 4th. If there was a 1 right below it, maybe I would have switched the rows. But if there's not, I'll just kind of use this technique here. So this is going to be 1 5/4, 1/4, 0. Hey, by the way, I'm really counting on those of you paying close attention to me right now to let me know if I make a mistake, because it's going to be very sad in the end if I don't copy some of the numbers over correctly. Then we move on and we go down to where that 2 is, and I want to make that 2 into a 0 to make it match the identity matrix. So we're going to take row 1 multiplied by -2, add it to row 2, and that will be the new row 2. So row 1 doesn't change here. Okay, when I do the second step here, -2 times 5/4, that's going to be -5 halves. -5 halves plus 3. Well, 3 is really 6 halves, so that to me should be 1/2. So if I did that correctly, I'm going to pause there. Yeah, that sounds good. -2 times a 4th is -2/4, which is -1/2. -1/2 plus 0 is still -1/2. This is just going to stay a 1 at the end, right? -2 times 0 is 0, plus the 1 is still 1. All right, moving right along. We don't want 1/2. We want there to be a 1 there. So you're going to take row 2 and multiply it by 2. It's kind of a nice step. So the top row stays the same. The bottom row is now 0, 1, -1, and 2. And we've got one step to go to find the inverse. Change that 5/4 into a 0. So I'm going to do -5/4 times the bottom row. Oops, not change, plus R1. That's going to be the new row 1. So row 2 stays the same. Top row is now 1, 0. That was the whole goal. -1 times -5/4 is 5/4. 5/4 plus 1/4 is going to be 6/4, which reduces to 3 halves. -5/4 times 2 is -5 halves, plus 0 is -5 halves. So I'm going to check the check quick, make sure that I didn't make any mistakes here. I didn't see anyone chiming in. No, am I doing okay here? Okay, so this matrix right here is the inverse matrix of what I started with. A inverse is the 3 halves, -5 halves, -1, 2. Okay, now that I have that, if I take that and I multiply it by matrix B, which was that right-hand side, 7, 5, that should give me the solutions for X and Y. So I'm going to take this right here. I'm going to multiply it by 7, 5. And as a reminder, when you do a 2 by 2, this is a 2 by 1 over here. The product is possible because these two things match. The result should be another 2 by 1 matrix. It's the rows of the first and the columns of the second. So this product is going to be the same size as this matrix here. So you're going to do the first row times that first column. It's kind of a lengthy problem, guys, but it's a good review of all the processes that we've seen with matrices. So it's going to be 3 halves times 7 minus 5 halves times 5. So that's going to be 21 halves minus 25 halves, which looks like -4 halves or -2. Constantly checking this chat in case I make a little mistake, but I'm thinking I'm doing okay. All right, -2 is the first element. Second one would be -1 times 7 plus 2 times 5, which would be -7 plus 10 for a total of 3. Do these have to be nice numbers? Not necessarily, but when they are, it makes our job a little bit easier to know that x equals -2 and y equals 3. Because if you look back at our original matrix X, that was defined as being X and Y in that order. All right, Addie, you might be getting a little bit more than you bargained for here, but I'm just going to show you how the calculator could have done this for us much faster. Now, on the test that I send you guys, there's going to be questions that say, do this by hand. Not for a lot of them, but I'll probably have you do this at least once using this inverse method. And then there will be some that maybe just say, do it on the calculator. So what would you do on the calc? You would edit some matrices. So go to edit, choose matrix A to be a 2 by, oops, I have to do edit. Here we go. Choose matrix A to be a 2 by 2. And the original matrix A, all the way from the top here, was 4, 5, 2, 3. Okay, I'm not going to even type in the inverse. I'm going to type in the original. 4, 5, 2, 3. Once you're done editing, you have to quit that screen, go to second matrix, edit matrix B to be a 2 by 1, which had 7 and 5 in it. Finally, if I quit that screen, if I do matrix A inverse, the inverse button is the same button I've been hitting second to get to, times matrix B. The product is, oof, I'm on my game today, guys. -2 and 3 is the answer. Plural, I guess, right? So I was kind of nervous there. I don't know. I haven't had to do math in person in a long time, so glad I didn't make any little sign mistakes. That's why none of you were chiming in, I guess. All right. So Addie, that's what that process looks like. And to be honest, yeah, I mean, it's a little bit involved, but it is a really good recap of, like I said, finding inverses, multiplying matrices down here. Those are also things that you might have to do individually at some point on the quiz. I might say, hey, here's a matrix, find its inverse. Hey, here's 2 matrices, multiply them. So it combines both of those ideas, which is why I kind of like it. But if I say to do it on the calculator, it's going to make our lives a lot easier. You will be sort of forced into doing it on the calculator if you have a 3 by 3 matrix. Because we don't know how to find, well, we know how to find it, but we haven't done it yet. We haven't done 3 by 3 matrices inverse by hand, so you won't have to do something like that. All right, what else can I help you guys with? That was a good one to take care of for sure. Took me a whole page to do that one, guys. Okay. Anything else from the review or otherwise earlier in the matrices unit that you guys want to go over? Just a quick note, by the way, in number 14, it doesn't say this in the directions, but I would encourage you to solve the ones in number 14 using the calculator. They're the same types of questions that Addie just asked about, using the inverse matrix method, but try setting those up using the calculator. All right, Angelica says, I'm confused on what's the difference in RREF versus REF. That's a good question, Angelica. So the difference is, if you think about what the staircase looks like, if there's zeros above the steps or not. So RREF, if you were, let's say, solving a system, would look like this, where you have ones on the steps, zeros underneath the steps, but you would also have zeros above the steps, above the ones there, and then have numbers on the other side. Versus if I just said REF, you only need ones on the steps, zeros underneath the steps, and then what's above those ones could be any old numbers. It doesn't have to be zeros. So that's kind of a nice side-by-side view, I think, of what those two forms look like. When we're solving the system by doing those row operations for a 3 by 3, we've been using REF. Because when I get down to this last step, I don't have to go do all those zeros up there still, and I know that z equals this number. If I know what z equals, we come up to the second equation, substitute in there to find y, and then come up to the top equation to find x. If you're willing to put in that extra effort to make the zeros above and go to RREF, you directly have the values for x, y, and z right away. So that's kind of nice that if you do put it in this form, x equals this number, y would equal that number, and z equals this number. But it would be a lot more row operations to get all those zeros there. So I typically would say stop in REF, find the value of z, and then do that back substitution process. The only quick note about that is when you're finding an inverse matrix, you have to have the identity matrix on the other side, which kind of looks like this, right? Like that RREF format almost. So make sure you don't kind of shortchange that inverse process. Hopefully that helps, Angelica. All right, these are very good questions. Anything else I can help you guys with? Not seeing necessarily anything coming up in the chat right now. So maybe that was it for today. Maybe you just wanted to check in and see some of your classmates too, which is totally fine by me because it's been too long. What do you guys think? Anything last minute? What I'll do is let me give you just a quick heads up about today. Actually, right after this, I have a faculty meeting, and I don't know what I'll learn from this faculty meeting that you guys don't already know. But as I find out more information about Q4, I'll share that with you. Once I have my grade set for Q3, I'll share that information with you in an email as to how those grades were calculated. And I appreciate the effort that you guys are making by coming on today and getting a little bit of extra practice with me, because I think it's important to kind of connect in this way, you know, even though we're not really having a chance to talk to each other as much when everyone's muted. You know, I like just doing a quick share out of how everyone's doing and, you know, doing a little math on the side of it too. So, but as soon as I have more information, I'll send that to you. Angelica says, do we need to submit the review? The answer to that is no. So what will happen is tomorrow, I'm going to send out the matrices test. That's the only thing you'll have to submit to me by Friday. So hopefully that timeline is sufficient for you guys to complete it. It's not any longer than an in-class test, but in case you have a lot of other things you're balancing this week, having tomorrow and Friday to complete that should be plenty of time. And then we get to start a new unit come Monday. So, but yeah, once you're done with the review, what I'll actually do is I'll post the answers to the review too. So this way you can check in on those. And if you have any questions about them, you can send them my way. All right. But again, I do appreciate you guys taking the time to come today and ask me some quick questions. Keep in touch. I've had actually some small groups meet with me. So if you would prefer, I mean, we only have 10 people total here today anyway, which is a small group. But if you have, you know, you and a few friends want to join up and meet for a little while and ask some questions and not have it in a whole class setting, that's fine with me too. You just got to reach out and let me know. Max says, are there any practical applications for matrices? And the answer to that, Max, is absolutely yes. You know, when you encounter complex situations with lots of variables and lots of equations, matrices and operations with matrices can make the solving of those systems of equations much faster than our work that we typically do by hand. So we've only looked at 3x3 systems with 3 unknowns and 3 equations. I think I showed one application. I think actually Addie was in it, Sean was in it, and maybe Alexis. Right? I think they were buying pants, shirts, and socks or something like that. So that was kind of a silly way to connect it to some real world stuff. But yeah, I would say that in the real world, where with more complicated situations, computers can use matrices to solve systems like this much faster than we can on our own. And I would say that if some of you are in computer science, I know that you guys talk about maybe matrices and arrays and things like that. And certainly computer programming could be set up to solve systems of this form. So we'll even see more matrices in the next unit a little bit in unit 11. And we'll see other ways that we can really quickly get answers. But before I can give you the quick way, I mean, you know how math works. We got to show you where it all comes from first, how to do it by hand before we just type a bunch of numbers in the calculator and not know what's happening there. So hopefully that was a good quick answer to your question, Max. Anything else you guys have for me, whether it's matrix related or otherwise? All right. Thanks so much for coming out today. Sean, happy birthday. If I could give you bonus points right now, I would, but there'd all be fake bonus points at this point. So enjoy your 18th birthday. Like you said, eat a lot of food. What is the food plan, by the way? Anything good?
I think we're having some steak for dinner, so excited about that.
That is a good plan. I like that plan. All right. Well, eat lots of steak. Enjoy some birthday treats, and I'll let you guys know next week if we'll probably have maybe another meet at the end of next week. Okay. But if you have any questions about the review sheet answer key, let me know. Otherwise, the matrix test I post tomorrow will be due Friday. Okay. All right. You're welcome. We'll see you guys later. I'm going to hit stop record. Waving goodbye to those of you. Waving goodbye to me. Oh, you can't see me because you see my lovely document camera here, but all right. We'll see you guys soon, I hope. All right.